This is one of the gauges that we are installing. This will give the level of the river or the stream, and this will give the actual velocity of the stream. So there's two different radars in this one instrument. Both of these radars are reporting back continuously to the actual gauge equipment, which is keeping track of it, and every 15 minutes it's sending that information via a cellular modem up to the cloud where that data is being ingested and then put into a portal for TxDOT personnel to have access and to use.
What we're looking to do, or what we're trying to establish, is whether or not we can better forecast flooding on our TxDOT roadway systems. And the research that was done through UT, the National Water Model, trying to understand how we can do a better job forecasting flooding.
We would start with Interstate Highway 10, and we would instrument that at intervals along its path from San Antonio to the Louisiana border.
We're seeing this as sort of a pilot project, kind of a proof of concept, to put down a network of gauges to supplement the existing gauges that exist throughout Texas.
And with that, we'll be able to more accurately understand the likelihood that I-10 will be flooded, and also be able to forecast that, so it's not just we're going to have to close I-10, but we anticipate being able to that I-10 will be closed in 3 hours, for example, so that traffic can be diverted onto other roads and not just come to an endpoint somewhere and suddenly there's no place to go.
During Hurricane Harvey, for example, one of the decisions we had to make was along I-10. We kind of knew I-10 was going to flood. We didn't know quite exactly when, but we knew we had long traffic routes, right? People going from El Paso all the way over to Houston, right? Lots of commercial truck traffic, travelers. If we could let them know before they got to I-35, maybe they could take I-35 up and around. But if they came all the way into Houston and then we shut the road down, then we had a lot of people stuck on the more minor roads. So not just kind of at the micro level of shutting down road by road, but at kind of a statewide system level, trying to understand what's going on. Yet another benefit that we see here that we're hopeful for is the first responders need to understand the routes in. Just like for a hurricane evacuation route, you think people want to get out of an area, the first responders are trying to get in, but they don't know necessarily the best route in. The missing piece of information that we're looking to supplement with this project is, what's the level of the bridge when you see that curve going up and down from the Weather Service? You know, such and such river's going up and down, how high is it going to get, what's it going to crest at? But the elevation of the roadways and the bridge, if the personnel can see, okay, it's going to come up and flood the road here, and then it's going to come back down and not flood the road over here, you suddenly have kind of a time window, a projection of, we think these roads are going to be underwater for 2 hours or 6 hours or 2 days or whatever that is. And so being able to forecast that and anticipate it is what we're hoping to pull the information from the gauges to the website, and then the website can send alerts and notices to our response teams that then have to deal with how to shut down those roads.
There's kind of a symbiosis between the river network and the stream network and the road network. Those two things intersect at bridges. And what we're doing is really illuminating that intersection and making it more real in terms of how much water is actually there, what the threat is to the road system of high flows. We're not just talking about one bridge, we're talking about the whole bridge system here. Not just talking about one highway or one bridge on a highway, but the whole highway. And that's not something that we, at least I as a hydrologist, have really thought a lot about before.